Okay. Hello, everyone. The next speaker is Steven from Hong Kong. Uh, he's going to share his event sourcing experience in English for us. Yeah, let's give him a big applause.
Hi everyone, my name is Steven, and I'm a developer advocate from Event Store. And yeah, I'm from Hong Kong, and I'm very happy to be here in Taiwan today. And I want to thank DDD Taiwan for organizing such an amazing event. It's not easy to have such a big community on DDD itself. So before I start, I just want to get a hand on how many people have actually used event sourcing in production. How many people have heard of event sourcing, know a little bit of event sourcing? Hey, that's very good. That's pretty good. How about you guys? And who's here just to learn? Also very good. Okay, so just want to share a little bit of my journey event sourcing. I started development maybe almost 20 years ago, and I was in a big company. They were doing a lot of complex financial software, and I was frustrated because the solutions are just very complex, and it has a lot of spaghetti code and things like that. And when I talk to my boss is like, keep going, try to write better code, cleaner code. And he introduced DDD to me, and that was really life changing. And later on, as I started to learn more and more, I went to I read blogs, conferences, and so on and so on. I stumbled upon a course by Udita Han on CQRS, and CQRS really blew my mind with the flexibility and potential. But at that time, I was too young, and I don't think I really grasped the full potential of it. So moving forward now, I've done a few projects in event sourcing and CQRS. But one of the challenges I still have sometimes is to explain to younger developers, why do we use event sourcing at all? Right? For those who know, it seems to be a little complex. Why do we do that? So my job here today is to try to explain why we want to do it in the simplest way possible, so that hopefully you guys can get something for it, and maybe in the future, in your future projects, can use that. So to start off with, so there are many kinds of data in this world. So there are very simple data, like just what's the time of the day is, the temperature, and there's some more complex data, which depends on a lot of things. It changes over time, and it means different things to different people. For those that DDD, right, that's bounded context, a lot of a ubiquitous language between different users and departments. So some examples be maybe a customer profile, maybe a sales contract, medical records. So these are very important data. And even though they're complex, right, they're very important to business because there's a lot of insight and knowledge that you can get out of it, and many people depend on it as well too. So the problem with complex data is that when you have to scale your business operations around it, it becomes very hard. So say for example, if I have to write a website for Taylor Swift to sell his concert tickets, but I better make sure that my website can handle millions of visitors per second. Make sure the ticket sells, of course, but at the same time, I don't want people to be double booking the same seats, getting into problems. Of course, stakeholders want their reports in real time, all the time, and make sure the dev teams are ready to troubleshoot at any time. Well, it may sound easy, right? But it's very hard, this kind of problem. And as an industry, we don't really do a good job on it. Often it can cost millions of dollars. It can take months or years to develop a big team. chance of failure is high. It's risky for a business to invest in it. And for a lot of software leaders, like this is equals to a lot of like many sleepless nights. So one of the reasons we think this is happening is because we think that there is a problem in the industry with transforming data in general at a bigger scale. And traditional databases are not very good at data flexibility and consistency. And I'll explain this more in a bit. So when we're talking about data flexibility at the source of truth sort of database, we're talking about like how you can actually transform data from, like, say, one particular form to another. And this gets really important if your data is core to you, because you need to spread that data to all kinds of different users and audiences. So say, for example, in the Taylor Swift example, like your customers might expect, they might expect a high-performing cache, right? Because you need it to, like, it needs to handle like millions of users. Executives want financial reports. For it, you need to transform your sales data into automated emails for customer notification, maybe. And the dev team needs to handle, of course, like a lot of like domains and UI models as well too. So the core of the data, like we want it to be as malleable, means like most flexible as possible, to be able to transform it to any kinds of shapes as possible, to fit, to optimize what your users actually need, right? On the other hand, if the core of your data is inflexible and it's rigid, right? Like all you get is the same kind of stuff. Like when you have to transform things, they might not be like very optimized for what your user actually needs. So consistency, on the other hand, is like the yin and yang with flexibility, because, well, you can transform data all you want, but when you do transformations, if there are bugs, if it becomes incorrect, then it's not very useful at all. Right? So traditionally, databases are very good at consistency when we're talking about like on a transactional level. Okay, but if we talk about the other kind of consistency, right, and we're talking about eventual consistency. So these are things like batch jobs, ETLs, asynchronous messages. Then traditional database seems to just kind of fall off. They don't have the mechanism or features to support developers to develop good, like consistent transformations. Oh yeah, and also like, well, the big challenge with eventual consistency is, of course, like when you send things like asynchronously, you get like network loss, ordering problems, duplication problems as well. And again, traditional databases are not very good at like helping developers for that. So let's talk a little bit about event sourcing. So what is it, right? So first of all, it's an application pattern. Okay. And there are two parts to it. So your database, the source of truth in the event source system, is stored as historical events rather than states. So this is a really important distinction. The second part is that the events themselves are state changes and they represent past business actions. This is also very important. I'll break this down in a bit. So what do you mean by current state and historical events, right? So think current state, an example I give is like your credit card account. Okay, in a credit card account, you have like first name, you have your name, you have addresses, you have your credit limit, you have your balance, how much you owe to the bank. So that is the property of right now. That's your current state. Okay, we also call this a state-based model. Historical models, historical events are like what has happened to your account to actually reach to where you are at right now. So you opened an account, you spent some money, you paid off your credit card bill, your credit limit got increased, maybe you changed addresses, and all those things kind of lead to the current state of where you are. So both ways are the same way of representing who you are, but in a different way. One is with the state and one is with history. We also call this a event-based state transition data model, or a event-based model for short. So example I'm going to use is a driver tracker application for a logistic company. So say I have a very a simple database. You can see my table has just the name of the driver and the coordinates. And imagine this is just a map. I know you can't really see the lines in between, but imagine they're all roads going across and going up and down. And as the driver moves across the city, the coordinates get updated, right? And eventually, if I reach to the end, then yeah, my final destination would be recorded in the table. Okay, so we call this a state-based model. And notice that it might be obvious, but the location changes every time we move, and the previous value is not kept. So we call this a rather lossy model because there's data loss every time we do an update. And information gets destroyed in the process. So that's a key point there. On the other hand, if we store this in an event-based way, what we have here is a series of directions starting from the beginning. You see the time, we have the time here as well too, starting from 1, 2, 3, and 4, 5, 6, 7. And when you look at this representation of the same trip, it might not be immediately obvious to you where the current location is. But if you go down if you kind of walk through the series of steps and go through the map yourself, then you can eventually lead to the same final location that we had before. And this is the event-based model, how we call it. And the key characteristic is that the data itself is lossless because we keep all the information of how the state changed over time. And this turns out to be something that is really helpful. So when we compare the two models, there's no one single model that is the best fit for everything. If your application needs to just look at the current location and you don't really care about how the driver drove, where he went to, and so on, then just stick with it, right? It's quick, it's direct, it's simple, right? Why do you have to go through the complexity of calculating all these different paths? It makes no sense. But if you look carefully for the event-based model, it seems to give you a lot more information, and those information can turn into a lot of insight as well too, compared to the current base one. So if you're more interested about the how, how did we reach here? Why did we come here? Then the event-based model is a lot more suitable for answering those kinds of questions. It also, the other big benefit is that it also has a built-in audit log as well too. So audit log is extremely important because, say if you get into conflict with your users, as the sales manager, I get calls from sales manager all the time and I really hate them. They come and they say, hey, your report is buggy, my sales is down and it's your fault, right? And well, I pull up my audit log and say, hey, look, one of your sales was doing something that he's not supposed to do in the database. It deleted something. And so just F off. And having an audit log really helps you to prove that your system is actually in a good state, right? The same thing happens as well, not just with users, but to external systems that you have to integrate to your downstream systems. When you have something like this, then all those problems about network losses, duplications, ordering problems, they're much more easier to solve because you have something to go back and troubleshoot with. And this really helps to improve consistency when you have to do like eventually consistent operations. So the second property is that the events are state changes that represent past business actions. And when I'm talking about so I said that historical events are great at portraying insights and information and knowledge. On the other hand, if the events themselves, how they're named is very important. And if you're able to name it in a way that fits the business action as much as possible, then you really enhance and increase the amount of insight that you can get out of it. So when you have names someone placed an order, added something to a cart, and customer added an address, it really clears up what the user intention is for this, and this is really helpful for customers. And I think in DDD, of course, this is a form of ubiquitous language, something that fits more with the business. On the other hand, if your events are named just order updated, cart updated, customer updated, it's kind of confusing, right? What are you updating? It's very hard to kind of see more, and you kind of lose an opportunity to give more meaning to the data. So an example, say a streaming service, right? And somebody a developer came and created an event okay, subscription is updated, my status is active. Great, okay, I know it's active, but what's the significance of it, right? To a business user, they'd be okay, are we talking about did someone renew something, or is this a new sign up? Because these mean totally different things when you have to analyze data. Would it be more interesting if they named it, okay, a subscription got renewed after it got expired, maybe a new subscription signed up, right? So these are a lot more interesting, and I would call unambiguous event names. Just give you a few more examples, right? So say a vehicle rental service. What does it mean for a vehicle to be unavailable, right? Does it mean that is it under maintenance, or has it been reserved to a customer? So that is, again, it's confusing. Yeah, so next is, a flight reservation service. So calling it first class, okay, did customer actually pay for the upgrade, or maybe got overbooked, and so we have to, give them a first class seat? These scenarios are very, very different. So I personally call them an intent confused state updates, because the intention behind all this is unclear. And this is a big problem in the industry, is that not only do we lose data, we also kind of lose the intent behind why the data is updated in the first place. And when you do event sourcing, if you name your events correctly, then it really exponentially clears up a lot of the confusion. Okay, just quick recap. So event sourcing, application pattern. So we got it's historical events, and we also model the events as business actions. So the benefits of event sourcing comes in two folds, right? So we have the flexibility, the ability to actually transform your data from one form to another without, with the data that has not been lost, right? And so you can actually transform that into many different kinds of states that the state-based model cannot do, right? And with the audit log as well too, it gives you a lot of consistency so that you can synchronize with other systems as well as users better. This leads to better transformation and deeper insight ultimately. And with traditional databases, it's lossy, log and log. So again, that's kind of like some of the reason why it doesn't do that transformation as well. So just want to introduce like some of the superpower of it. So one, I call it the shape shifting because it's just flexible, just like Mr. Fantastic. So to go back to the example and just to give you a little bit more like detailed explanation on how that transformation is like. So try to answer this question, right? So what's the total distance traveled for this trip, right? I mean, if you look at the state-based model, you can't really tell. But with the event-based, then you can just go down here and kind of calculate like the distance itself. What is the total distance on road E? Again, like maybe like this road here, maybe it's a highway, and we want to calculate gas mileage on here differently from the other parts. But again, yeah, in an event-based way, then we can just run it back and see where he was and calculate that segment. But again, with the state-based approach, when you lost all that data, you can't get it. And you can see, like, what I'm trying to get to is that there are a lot of questions that you can't really answer, and some of them are very important. And these are the different kinds of transformations I'm talking about, and that the event-based model is flexible enough to transform itself into structures that can actually answer these questions where the current state model cannot. Another superpower that I want to talk about is the ability to actually decouple like your solution stack. And when I talk about the solution stack, like I'm not talking about just like the technical, like your database or hardware. I'm talking about all the way from technical to business, to the code, the design, the business model, and so on. Traditionally, our entire solution stack often is tightly coupled to the database. And this is not so much of a problem if you're in a very, like if your operations are quite simple, but when you have to start optimizing your stack for different use cases, so maybe I need to optimize it from use case 1, and then another business user comes and I want to optimize it for use case 2, and then for 3, for 4, for 5, and so on and so on. Your stack becomes extremely overloaded because it wasn't designed like for all these different use cases in the first place. And what happens is like after a long time, right, you get into a lot of problems. So maybe your server like it gets overloaded, your database gets deadlocks, the indexes are not working anymore, your code is too complex, and what happens is your business is now stuck in the past and cannot change, right? So if you really think about it, like some of this is really caused because there's a tight coupling between the stack and the actual model in the database itself. But we talked just now how event sourcing can actually help transform that into many different kinds of states, into different kinds of models, right? Why don't we have a model that actually is optimized for each of the states so that this poor state here doesn't have to be doing so much, right? And that's exactly what we want to do. So with the event store, we want to have maybe like a stack, a model that can be used for a stack that is optimized for, say, performance. Maybe a stack that is optimized for analytics. Maybe a stack for integration to all the kinds of different systems. And because of the audit log, you can keep all these states consistent. It's much easier to do that than before. And so now you have stacks that won't be actually overloaded. So I'm going to go deeper into some of the details of what each of these mean. So take for example, like okay, if you want to decouple the infrastructure. So say if you keep all your data inside like an Oracle database, right? Oracle database has relatively higher hardware requirements, maybe 4 CM class, like a server class, like CPUs, 8 gigs of RAM, maybe a few hundred megabytes of space. But if our source of truth is not stored in Oracle, we don't have to actually replicate to oracles anymore and on other systems, right? Why not just project to a SQLite? SQLite, they can exist inside like an IoT device, like just a small tiny device with one like a Atom core CPU in there, and maybe it just takes up like 40K of space, maybe. Why not just project it to a SQLite, right? And that means that like you're not tied to the hardware itself. You can project it to like a lot of like different kinds of hardware. You're not so coupled to your vendor anymore. Say your cloud database, of course, it doesn't support like a lot of multi-cloud databases, but with event sourcing, then you'd be able to replicate your data like to different kinds of clouds as well too, because again, with the audit log, you can keep all that data consistent. If we go to database platform, right? We talk about so it's very common in event source applications to project itself to many different kinds of databases. So, and you'd want to do that because every database has its own unique advantages. So say I want to optimize, just general query, then you want to go with just relational, really, because everybody knows it, it's easy to learn. But if I want to do like multi-dimensional query on like big data sets, let's go with analytic OLAP databases. You want to go with like Redis or something like that for high performance reading, message brokers for publishing events integration. And funny enough, I say flat file because why do you need a database anymore? Like when I can just project my events into a, like say even like an HTML file, and then have that updated to my CDN and immediately served for there. So like why do I even need to store my current state inside a database? And a lot of our clients actually do that and has good performance. I mean, that's faster, that's gonna be faster than any database you find. So we talked about like database schema and how to project to different forms. And we explained how, okay, say like maybe for the finance users, they want to maybe calculate what the total distance traveled is for everybody. Maybe they want to do a forecast. US operations team, they want models that actually are defined in miles instead of km. What does Taiwan use? Does Taiwan use kilometers? Yeah, and liters probably, right? Like everybody else do, like entire world, right? But yeah, but for US operations, they might want to do it in miles and gallons instead. So again, you can transform these into states that they prefer, maybe. But another interesting ability that this actually gives is that you can decouple like external systems from the dependencies of your schema. So let's go into an example, right? So if I have a database, again, and it's storing my coordinates in my past example, and say this is actually used by a lot of different external systems. That's great, it's popular. people are using that system. But say one day, like one of the users actually don't want you to store things inside like with coordinates anymore. Like you should be using like longitude and latitude, right? I mean, like, yeah, who would have thought of that, right? And this traditionally would be an expensive change because you have a lot of users using your systems and you really don't want to just kind of break their system and just make the change. And so there's a lot of coordination that you have to do and so on. But if we were to use event sourcing, then say you can duplicate your state here. You can design another one that actually uses longitude and latitude instead, and just ask your user to switch over to that. And furthermore, if whenever your other users are ready to jump onto it, like they can switch over to that new one as well too. So this is a very powerful tool when it comes to migrating away from legacy systems. If you have databases that you find are like super huge and so many people are depending on it, this is something that event sourcing can really help with. And finally, we talk about the business model. So when we talk about data, we usually think that, okay, the data model is dependent on the business, its requirements, its users, like that's where all that data model is driven from, right? On the other hand, there's dependency from the business, like on the data itself too. They're both kind of interdependent. I've seen a lot of leaders and they want, business leaders, and they want to use application to actually change the mindset of their staff and of their users as well too. And that's why they develop applications for them. So business model is able, like your data model is able to change the actual business model themselves. And when you can design, like with event sourcing, new business objects and processes quickly, then you can change a lot of the business concepts and the mindsets in the whole company at scale. Okay, so just to give you like a more concrete example, so say I talked a little bit about how we want to optimize, a specific stack for a specific use case. So in this case, my use case is I want to optimize like display of concert tickets availability. So imagine like I'm trying to buy a ticket. I want to know like, okay, is this seat still available, right? So how do we optimize the stack to achieve that? So start from the business model, right? Okay, in this case, like we want to really reduce race condition so that people don't just keep trying to buy the same good seat and crash the server in the process. And so maybe from the business model side, like let's not really talk about selling individual seats. Let's sell like in terms of sections instead. This is very common, like when you go to concerts, that they're not just going to open like seats for you to actually pick. And so this is something that we can like discuss with the business and tell them, okay, let's not model it in the same way that we used to model it, which is maybe just seats. Let's also try to use like different processes for the actual crafting of the availability. So we can have like a process that subscribes to like all these sales events, and in memory maybe keep a counter of how much seats are available for each section, and try to update the cache when that section is not available. Okay. And a lot of times I see that the code itself, it's it's much cleaner, like when you separate out the writes and the reads, and you get better separation of concerns from that. For the data schema, we want to use just like a simple key value pair, just maybe a section number and it's available. We don't need all that mumbo jumbo about the seats, like okay, the seat number or who bought the seat, all that kind of properties, we don't really need it. Like for this cache, all we need is just a section and availability. Database platform, yeah, we probably want to use something like a Redis that is behind our API to grab that. And we want it to be configured for replication so we can serve like many locations. Again, like here, we're not stuck to the relational database or the source of truth. Like we can replicate it to other places. And for the infrastructure, we can choose like the cloud vendor that we're familiar with. And maybe like for cost reasons, right? Again, we don't have to be stuck to how the relational database or the source of truth is actually hosted themselves. So just to recap a bit. So again, like in this case, we sort of have an optimized stack for like a performance. But again, we can do the same for like analytics, where we have maybe this is hosted in like a data warehouse, maybe internal on an on-premise server with a data model that is like customized for multi-dimensional search. Again, like different stack for integration. So in this kind of way, we don't really have to worry about your stack actually being overloaded for other people's reasons. I just got to fix it more. So just a quick recap. Okay, so before event sourcing itself, okay, there are two parts to it. So what we are is we have historical events, and the events are business actions. It gives a lot of flexibility to transform your source of truth to many different kinds of forms. And also it gives you a lot of consistency, like helpful ways to manage consistency as well too. And that leads to a lot of good transformation and deeper insights as well too. We also took a look at shape-shifting, like how you can change forms to different things. And we looked at how we can decouple your solution stack and optimize it for specific use cases. There's another superpower that I left out didn't talk about, like because of time reason. But quickly talk about it is that, of course, like you can go into your system and go back in time any time. So if you, of course, everybody use Git, like I hope. And Git is a very good example of like a kind of like event sourcing, because you can always go back in time and see your history. And also you can also construct your source code like at a particular time as well too. So this is what event sourcing can give you. We have retroactive updates, so similar to Git as well. It's like, well, in Git it's a little harder, but you can actually have like a retroactive updates to say that, okay, at a past time, like my data was actually incorrect, but now this data this time is correct. But unfortunately, I don't have enough time today to go through that. But that is a retroactive update is a very interesting use case in event sourcing. So is event sourcing a silver bullet? No, like definitely not. You don't want to use it everywhere for sure. And I think just now Flag was talking about the kind of different systems, and in PDD you have like core domains, supporting domains, generic domains, and so on. And I would say like a core domain is somewhere where it would be useful for event sourcing, because that's where a lot of change and a lot of complexity is. So definitely don't use it on really simple data where nobody really cares. So one thing I can think about is like config files, right? I don't think you're going to be like distributing your config files to your CEOs anytime soon. So like stuff like that. Well, but that's unless like you're in like say AWS and you're keeping other people's config files and you want to make sure that so if config file is actually important to your business domain, then yes, right? So when we use event sourcing properly, it's going to drive your development costs down, improve data quality, and performance and scalability. But the end goal is that we're talking about like data being locked up in your traditional database and not being able to integrate well with other systems because of all those, again, like the message loss issues, coupling, ordering. But event sourcing makes it easier to kind of spread that information out, but also gives you a lot more insight because it has just a lot more data inherently to share about the past. So we want to improve the distribution of knowledge, and the end goal is to, create a lot of good insights to help solve real complex problems in the world. Okay. And so with that, I want to say thank you. I have a lucky draw here. And if some of you want to get some nice goodies from Event Store, we have a really nice plushie that we give out. And please sign up to the survey. Please give me some comments. I would really love your feedback. And with that, I want to say thank you. So just any questions?
Deal with the event schema problem or event schema checklist.
There are kind of few ways to do that, right? And so like Greg Young, the founder, he almost wrote a book on that, events versioning as well too. So it really depends if it's like a real big breaking change or not. So sometimes the change when you're talking about just like say your event, if you need to add just like a new field. So first of all, think of it as just like a database schema, like a transform. It's pretty similar. If you need to add a new column, right? And that's not gonna, like when you add a new column, it's not a breaking change. So just add a new field to your event. So that's pretty simple. Unless you really need to change the meaning of your field or the actual meaning behind the event itself, then you don't really need to introduce a second version of it, right? But when you do, you have to do probably like conversions and so on to migrate from one stream to another stream to actually do that. So, but there is like a big long book that's written about it, and there's a lot to get out of that.
Do you use the strong schema solution or the weak schema solution? Do you write schema for your events?
Oh, like strict schemas. I have not actually done that personally myself. The answer to that is no. Okay, with that, so thank you and enjoy your lunch.